Okay, so let me define polynomial now that we know monomial. So a polynomial, oh, what's poly mean?
Many.
Many?
Many numbers.
And nomial means like the stuff I was just talking about, right?
Yes.
You're supposed to know that?
Yeah.
So a polynomial is going to be many of the stuff I was just talking about, right?
Many monomials.
So a polynomial is a finite.
Okay, all right.
Sum of monomials. Cool?
Finite.
Finite sum.
Yeah.
So there's
Unless you slap the word Taylor in front of this. So in Calc 2 you're gonna learn to make a thing called a Taylor polynomial, which is not a polynomial.
I see for the
Terrible
Taylor
name.
instability. Taylor it's like an equation.
Possibly the same guy, I'm not sure. Taylor, yeah, this
When
Taylor
you
was
put
a,
coffee in the milk and like it creates swirls. It's like there's an equation to kind of like model that.
probably the same guy. Yeah, that would be a useful thing to think about. You guys cool with this?
Yeah.
So, a polynomial is a finite sum of monomials. So, let's make our similar example, non-example list.
So is the proof for E a non-example?
Yeah, so back in the day we did this thing where we said e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to
And then
the
you have
fourth.
those ellipses.
Yeah, and then there's those damn ellipses at the end.
Which
It
means
destroys everything.
go forever.
Right, so
Not.
that is not a polynomial. That is a
It's not finite.
Taylor series.
But like continuous?
Yeah, so that's an infinite degree polynomial, kind of, right?
So if you wrote x to the 1,000 over 1,000 factorial at the end of that ellipses, would it become a polynomial?
Yes. So if you stop that at any point, it's going to become a polynomial. So specifically here, I might do e of x, which is about e to the x, is say 1 plus x squared over 2 plus x cubed over 6.
Wait, so the fate.
Like if I stopped,
So I feel like the fate of the Taylor series is to become a polynomial, though, right? Like
yeah, the use of a Taylor series, like the use of one of these things is to have a calculator go out 1,000 places and stop.
Yeah, exactly. So, okay, that makes sense.
Right, so that the use of these things often truncates them into polynomial land.
Truncate. Right.
Yeah, you like cut it off, forget the end, right? Like a lizard losing its tail. Still not nice to do to lizards.
Yeah, don't do that.
Okay. So I stopped. Now let me check that this satisfies the definition. So to check that this is a polynomial, I need to go through each thing that's being added and ask, is that a monomial? Right? So
Yes.
with 1 here, do I have a number or a variable to a natural number power or a product of those?
Yeah.
Yeah, I think so.
1's a number, right?
Yeah.
X is a variable to a natural number power, specifically 1. X squared over 2 is
An integer and 1/2 times a variable to the power 2.
close. A number,
Yeah,
1/2,
so
right? Which is a rational number. But 1/2 times x to a whole number, or natural number power 2.
Same thing for the last
And
one.
same thing for the last one.
One.
And same thing for all the rest, right? Like even if you go out to 1,000 factorial,
But you stop.
so 1 over 1,000 factorial times x to the 1,000 power, that's still going to be a mono.
Yeah.
It's a very large.
You guys cool with that?
So cool.
Okay, so other examples, let's see. L of x, say, is, I don't know, 3x plus 2. What kind of beast is that?
Line.
That's a line, right? So all the lines are polynomials. parabola looks like,
Like X.
say, f of x is
2x squared plus 17.
2x squared plus
Why?
17x minus 37, right?
Yes.
Just because.
Okay, so that's a parabola.
Parabolas.
And I'd probably call that a quadratic function in here, but, because really its graph is a parabola. This thing here is a quadratic function.
Very nice.
Are all quadratic functions polynomials?
Yes. Yeah, so all quadratics look like ax squared plus bx plus c, right? Where a, b, and c are numbers.
But you could just have x squared.
What if there was like 2x
and
squared
c
plus
zero.
17x minus 37 all like square rooted?
Good. If
Is
there's
that
a
a-
square root in it,
Then it's to the half power.
then it's a thing to the 1/2 power, right?
And then it's not. It's not.
So it's not going to be a polynomial, so that would go over. So, nice. Square root of 2x squared plus 17x minus 37?
So just square root of X is not a polynomial?
And square root of x is not a polynomial. Square root of x wasn't a monomial, right?
Yeah.
And since a polynomial is just made out of monomials, right?
If something's on one number, I can't.
If something's not a monomial, it's definitely not going to be a polynomial. How about this identity function of x is x?
Well,
Is that an example, or did I just put that in the wrong column?
Well, a finite sum of monomials could include just one.
that's right. That's
Yeah, one is a finite thing.
Right.
Right?
Yeah.
So a sum of one monomial,
Is a monomial.
right, which really isn't a sum, it's just one monomial written down.
Yeah. 0.
Cool. Questions, thanks?
What
Where
if-
do your trig functions go?
Non-examples.
Yeah, those are non-examples. So all the trig functions are over here. Where do all your exponential functions, like where's 2 to the x live?
Okay.
Non-examples.
That's a non-example. Guys with me on this? Where does x to the 17th minus x squared live?
Because they're all
So-
full number powers.
Say f of x is pi x to the 17th minus the square root of 37
What?
x squared.
Square root.
Square root of 37 is the number.
Yeah, keep in mind, right? The numbers are allowed to have square roots in them. It's just the x's that aren't.
Okay.
So would X over X be a monomial?
It's 1. So yeah.
Is X over X?
No,
Oh,
because
it's also
x over x isn't always 1. That's that problem with 0 to the 0 I was having. So-
You have 0 on the bottom.
If I put g of x is x over x, right? Your natural inclination would be to say, but x over x is 1, dude.
Except when it's 0.
But
Except when x is 0, in which case it's not. It's undefined. You guys see that?
Yes.
So I'm going to try to say stuff like this, this stuff is, polynomials are always continuous,
Yeah.
right? And so in order for me to say that, I have to say that thing there is not a polynomial,
It's not us.
because that's x to the 0 power, right?
can be.
It's not continuous at 0. No, this thing is literally x to the 0 power. Cool?
Yeah.
Questions, Steele? Okay. All right. Deal.